Hello, I'm Narayanan, final year chemical engineering student, and this is our TARP project review 2, and our topic is machine learning based spo2 computation using reflectance pulse oximetry. And we are a team of 8. My teammates are harsha, madhan, sakti, priyanka, ghathyayini, uday, kiran, and rohit, joshi.
Pulse oximeter. What is a pulse oximeter? A pulse oximeter is a non-invasive small clip-like device that estimates the amount of oxygen in your blood level. It fixed to a body part, most commonly it would be a finger. It does so by sending infrared light rays into capillaries in your finger, toe, or earlobe, wherever you keep the device. Then it measures how much light is getting reflected off the gases. A reading indicates how much percentage of your blood is saturated. That is known as the spo2 level of your blood. This test has a 2% error window. That means either the reading may get differ from 2% higher or lower than the actual blood level.
Hello, I am Shakti Priya and our project is machine learning based spo2 computation using reflectance pulse oximetry. Among the vital parameters, hemoglobin saturation, that is spo2, is monitored continuously in the bedside intensive care and must be maintained in an adequate range to ensure tissue oxygenation. Since a person cannot be reasonably expected to continuously be at the person's bedside, specific medical devices are aimed to be ventilator settings and adjustment may help improve the quality of life. Such are the physiological model that can simulate the cardiorespiratory responses to mechanical ventilation settings in the modifications. The first ones are not accurate enough to give the wide variety of products. That is, in clinical practice, they don't give exact results. In case of children, we need to be extremely careful. From the ever-growing sets of clinical research data could not potentially improve the clinical performance. To overcome this drawback, we are going to compare two types of machine learning models: artificial neural network and complex decision tree, to provide caregivers with the support and the decision making.
The working principle behind the pulse oximeter. Pulse oximeter uses an electronic processor and a pair of small light emitting diodes facing a photodiode through a translucent part of the body, usually a fingertip or an earlobe. One LED is red with wavelength of 660 nanometer and the other is infrared with a wavelength of 940 nanometer. Absorption of light at these wavelengths differs significantly between blood-loaded and blood-lacking oxygen. The oxygenated hemoglobin absorbs more infrared light and allows more red light to pass through, and deoxygenated hemoglobin allows more infrared light to pass through and absorbs more red light. The LEDs sequence through their cycle of one on, then the other, then both off about 30 times per second, which allows the photodiode to respond to the red and infrared light separately and also adjust for the ambient light baseline. The amount of light that is transmitted, in other words, that is not absorbed, is measured and separate signals are produced for each wavelength. These signals fluctuate in time because the amount of arterial blood that is present increases with each heartbeat. By subtracting the minimum transmitted light from the transmitted light in each wavelength, the effects of other tissues are corrected for generating a continuous signal for pulsatile arterial blood. The ratio of the red light measurement to the infrared light measurement is then calculated by the processor, which represents the ratio of the oxygenated hemoglobin to the deoxygenated hemoglobin, and this ratio is then converted to spo2 by the processor via a lookup table based on the Beer-Lambert law. The signal separation also serves other purposes. A plethysmograph waveform representing the pulsatile signal is usually displayed for a visual indication of the pulses as well as signal quality, and a numeric ratio between the pulsatile and the baseline absorbance can be used to evaluate perfusion.
Artificial neural networks are a subset of machine learning. Here, a machine learning predictive model was trained on a portion of labeled training data after the data had undergone pre-processing. The data variables are then predicted using the model on a testing subset with hidden class labels. So based on the values of the other relevant variables, we predicted the spo2 variables using artificial neural network based on the input data. spo2 variable predictions can be made using the function approximation that the ANN performs. The results are the probabilities of each of the three classes where their probabilities are 1 or some are 1. Using the backpropagation process, the ANN is trained using training data and tested. The weights are changed through supervised learning in order to reduce the difference between the anticipated and the actual spo2 values. Up until the error is reduced, the practice is repeated. Through the layers of the network, cycles of forward propagation and backward propagation were used to create the ANN classifier. Performance optimization is accomplished via backpropagation technique. Moving on to complex decision trees.
Talking about the complex decision tree is a supervised learning technique that can be used for both classification and regression problems. It is graphical representation for getting all the possible solutions to a problem or decision based on a given conditions. Decision nodes, where recursive decision rules are executed based on the input variables and values, are encountered on the way from the tree's root to its common leaf nodes. Each path represents a single observation with a label given to the target Y in the leaf node or classification at the end of the path. The Gini index served as the yardstick for creating subtrees. Reason for using this decision tree is this usually mimics a human thinking ability while making a decision. So it's easy to understand for the common people guys also. The logic behind this decision tree can be easy to understand because it shows as a tree-like structure.
Coming to conclusion part, the machine learning predictive model resulted in an algorithm with poor accuracy. The comparison of machine learning models showed that bagged complex trees was a promising approach. However, there is a need to improve these models before incorporating them into a clinical decision support systems. One potentially solution for improving predictive model would be to increase the amount of data available to limit overfitting that is potentially one of the cause for poor classification performances for two of the three class models.